Hello, everyone, and welcome to another chemistry topic together, which is dimensional analysis. Go ahead and set up your focus notes page. It's been a little while since we've taken notes in here. So, just a quick reminder, you have your topics, you know what we're doing today. You've got your essential questions, so you know what your learning should be today. And then you set up your date. So, whatever date it is that you're taking these notes, go ahead and fill that in. And then remember, you only need to write down the stuff in red. So, when I'm doing notes or other examples or things, you can always add extra things, but just to kind of save you some writing so you can do more listening and processing and thinking, you only need to write down the things in red or any example problems I do. You probably want to do that. So we're learning about something called dimensional analysis, which is a problem solving technique for conversions. All right, let's get into it. Let's see what this is all about. So I have a little bell ringer I want to do with you. So kind of a warm up problem. So let's do a math problem. Go ahead and take a look at this. Solve or pause the video and try to solve this problem before I go over the answer. Go ahead and pause the video. All right, welcome back. So I think you already solved this math problem. So let's take a look at this. Notice that you've got a 3x on the top and then you have a 3x underneath. What happens to that? Yeah, it cancels. Why? Because when you have the same thing on the top and the bottom, when you're doing dividing or ratios, they cancel. So it's kind of like the 3x and the 3x go away. So you really have like 6y over 2. And then, so 6y over 2. So the y, nothing's going to happen with that. Those letters just stay there. So really, you've got 6 divided by 2, which of course we know is 3. So really, 3y would be your answer. So when you look at this big math problem with letters and other random stuff, the answer is really just 3y. That kind of a problem is what we're going to be learning how to do today. Only instead of them being random letters, they're going to be measurements. That's what we're going to start talking about. All right. So to kind of help you understand or think about this, I'm going to use an example of this. Imagine that I came to you and I was like, or I was just thinking about my day and I was like, hey, I have to drop off some meeting materials at a colleague's house because, we're all meeting distance, but there's something that they need for a meeting. So I'm going to go drop them off at their house. All right. Well, I've got this wonderful little map app on my phone. So that's going to get me there, right? Well, that app only works if I give it some information, right? Like that map app has to be able to connect to a satellite so it knows where I am, so where my phone is located. And then I would have to be able to type in a landmark or an intersection or an exact address so that this app can find that on a satellite and then give me directions. Just having the app doesn't do anything. The app only works if I know certain materials. And this thing called dimensional analysis, which is kind of chemistry math, works the same way. You can do lots of different things with math and lots of different things with numbers, but if you don't set it up a certain way, this chemistry math is not going to be able to help you. Just like having an app on your phone that you don't know how to use, that's what we got to figure out. How do we use chemistry math to solve problems? So that's what we're going to be learning. All right, so we're learning about something called dimensional analysis. So again, red means write it. So here's where your notes start. Dimensional analysis, which I will abbreviate DA lots of times, it uses the dimensions, which are like the measurement units of a number, to convert to another number and its new unit. So for example, if I ask the question, how many miles is a 5K race? Maybe this is something you hear people talking about, like, oh, I'm going to run a 5K. Oh, I just did a 5K. Oh, sign up for this 5K. And you keep hearing about that, but you've always wondered, what does that mean? You could use DA or dimensional analysis to figure out how many miles is that? Well, first you would have to know that 5K stands for 5 kilometers. That's the first thing you would have to know. But then we could solve this number and unit and get to a different number that is how many miles, a new unit. To do that, though, we need to know something called conversion factors. And a conversion factor is a unit and a number that equals another unit and number. So for example, to solve this problem, I would need to know that 1 mile equals 1.61 kilometers, km. So it wouldn't make sense if I said 1 equals 1.61. You would think I was being weird. 1 does not equal 1.61 unless you put measurement units with it. So 1 mile does equal 1.61 kilometers. It also doesn't make sense if I just say mile equals kilometers. That's not true. But when you have conversion factors, you have a unit with a number equaling another unit and a new number. So these two things are equal to each other because they're thinking in different dimensions, different units. All right. So the steps of DA are just kind of like how you would use a map app. So you need to know where you're starting. So like your phone would have to know the starting location, connect to the satellite that says where your phone is. In DA, we say start by writing down the given. So you look at your problem and literally you think, what is given? What information have I been given that I could start with? And you literally would start by writing that down. It goes in the first spot in your math problem. Then you got to know where you're going. So to use a map app, you would have to know an address or a landmark or an intersection and type that in. For DA, you need to say, you have to figure out what new unit is the problem asking for. So what new unit do I need to try to find? Then we got how to get there, right? So you would have the driving directions that the map app would give you, that list. For the steps of DA, you need to set up conversion factors. So those ideas like 1 mile equals 1.61 kilometers, what you're going to do is you're going to put something on the top and the bottom so that the words cancel. So remember how the words are like the units. So you have some unit that was in your given and a different unit that the problem is asking for. We're going to set up conversion factors so those unit words cancel when they're on the same thing on the top and the bottom until we get to our new unit. But then we have to actually get there. So if we were using that map app, we would actually drive or use our bike or walk there. The steps of DA, you need to actually solve the problem. And that looks kind of like that bell ringer warm up where we multiplied numbers on the top, we divide numbers on the bottom until we get our simplified answer. Like in that bell ringer, 3y. That was our last answer. All right. So those are kind of what we think about the idea behind DA. Why don't you take your first break? So take a little break if you need to, pause the video, either go do something else for just a couple minutes, not a very long break because we want to keep going, but you could also just write your COSTA question, a level 1 question. Remember, this comes right from the notes, a definition, describe DA, list the steps of DA. That was what we just did in the red lines that you just wrote down. Or you've got that guide on Schoology to come up with other sentence starters. Pause the video, come back when you're ready after your first little break. All right. So we need to talk a little bit about math in science. So on a calculator, if you do this math, 98.3 divided by 65.2, your calculator gives you this answer. So we started with like 1, 2, 3 numbers divided by 1, 2, 3 numbers. And then suddenly we got 1, 2, 3, 4, 5, 6, 7, so many numbers on our calculator. Where did all those extra numbers come from? How do we know when we do a math problem like this, how do we know what part of this number is important? How much of it is allowed? How much is what we call significant? That's our next little topic we need to talk about. We need to talk about something called sig figs. The tricky thing about science is that in science, every number is earned. When you're taking data, those numbers are not just made up. Like when you read something off of a ruler or a thermometer or a balance, those numbers are real numbers. They're not just made up. There's a reason there's either 1 decimal or 2 decimals. A significant figure is one that makes your measurement more specific. So when you are earning those numbers, if you use a more specific thermometer or a more specific ruler, you get more significant figures. So for example, 3 meters is not a very specific meter stick. It was one that was just kind of approximate, like, oh, it's about 3 meters. But then if I say 3.2 meters, this is a meter stick that had some divisions on it. So I could read and say, oh, it's about 1, it's a little bit past the 3 and it's 3.2. Or an even more specific ruler that has divisions at the 0.1, 0.2, 0.3, 0.4. And then I could say it's right on that 3.2 line that I counted. And so I put that 0 behind it. This means, I don't know, it was just a little bit past the 3 and I had kind of guessed 0.2. This means I didn't even have any measures. Maybe all I had was like a 2 meter stick or a 3 meter stick or a 1 meter stick. And so I just had to estimate, I don't know, it's like 3 meters. It was like 3 meters sticks long. Every measurement is more specific and has more significant figures. None of these is necessarily better than the other because it depends on what you're measuring. Sometimes I don't need to be very specific, and sometimes I do. So this is considered one significant figure. This is 1, 2 significant figures, and this is 1, 2, 3 significant figures. So the rules for determining whether or not something is significant, I have 3 of them. So write this down, significant figures rules. Here's rule number 1. Every non-zero number counts. So if I have a measurement, 234 meters, 1, 2, 3 sig figs, every non-zero counts. If I have a really long measurement, I was counting the seconds until something happens, 11,928. This is a really specific measurement, so it has more significant figures, 1, 2, 3, 4, 5. So really specific. Instead of just saying like, I don't know, it was a really long amount of seconds, like 12,000. Well, 12,000 is not very specific because it doesn't have a lot of non-zeros. So the more non-zeros you have, the more specific your measurement, the more significant figures. All right, here's rule number 2. Placeholder zeros do not count. So placeholders are just numbers that make a measurement big or small. Those don't count. They don't make the measurement more specific, just big or small. So for example, 0.0094 pounds, a really small amount of meat that you bought at a meat market. So 0.0094, these are just placeholders. They just make the measurement part small. This is only 1, 2 sig figs. These are placeholders. 1, 2 sig figs. Or 0.000521 seconds. So something that happened really, really fast. These are placeholders. They just make the measurement small. 1, 2, 3 sig figs. Same thing if a number is big, 35,000 meters. So something that was really far away, but if you're measuring something really far away, you're probably not going to get down to decimal places. So it's approximate, 35,000 meters. 1, 2 sig figs. These are just placeholders. They just make the answer big enough for the measurement, but not more specific. So 1, 2 sig figs. One more, 100 milliliters. You're measuring out something for a lab. The amount of water is not super important, so approximately 100 milliliters. So if you measured out 99, that'd be okay. If you measured out 102, that'd be okay. So this is just one significant figure. These 2 zeros are placeholders. So placeholder zeros do not count. So numbers that make the measurement small or numbers that just make the measurement big but don't make it more specific, those are not significant figures. They do not count. All right, one more rule, 3. Exactness zeros do count. Okay, wow, zeros. So placeholder zeros are just numbers without decimals that make the number big or small. So these are placeholders. They just move the measurement number, the first number, the 2, to be small. A number at the end after a decimal is exactness. It was exactly 0.00025. That exactness zero says, I did not guess that 5. I counted it on my measuring tool. The 0 says it was right on that line. So 1, 2, 3 sig figs, exactness zeros. These are placeholder zeros. And this is what I was just saying. We know the measurement. We were able to read to that 0.0025 line. The 5 wasn't a guess. So that last 0 says it was exactly on that measurement line. Something like this, 0.100. There's no placeholders here. The decimal is staying right there, and the measurement starts right after the decimal. So that's what I mean by placeholders. It's when a number, the first non-zero is a ways after the decimal. These are placeholders. So there's no placeholders. This isn't just a non-zero. These are exactness zeros. So 1, 2, 3 sig figs. So exactness zeros are at the end of measurements with decimals. These were just placeholders. Let's try one more, 5.520. All right, so these are all non-zeros. This 0 is not a placeholder. It doesn't move the decimal. It's at the end of a measurement after a decimal. This is 1, 2, 3, 4. This 0 makes the measurement more specific, more exact. So it's an extra sig fig, 1, 2, 3, 4. Okay, so non-zeros count, placeholders don't count, exactness zeros do count. Those are the 3 sig fig rules. All right, let's do a little practice. So here are 6 numbers, and you're going to tell me how many sig figs are in each. Placeholder zeros do not count. Exactness zeros do count. Non-zeros do count. How many sig figs are in each of these numbers? Pause the video and practice. Process it, think about it, and then we'll check the work. Pause the video. All right, welcome back. Let's check sig figs. So take a look at number 1. 1, 2, 3 sig figs. Did you get it right? Non-zeros are always sig figs. How about this one? 1, 2, 3, 4 sig figs. Because the zeros are in the middle. They're not just placeholders because there's non-zeros on either side. They're more than just placeholders. They're exact to show it's exactly 2004. 1, 2, 3, 4. How about this one? Look at this. There's 2 ways to write it. They mean the same thing and they have the same number of sig figs. Because remember, these are placeholders. So just 1, 2 sig figs. Okay, now look at this one. These look really similar, but look, this says like that extra thing at the end, which tells you this is more specific. This has more sig figs than this does. They both have a bunch of placeholders, but this is 1, 2, 3 sig figs because of that exactness zero at the end after the decimal. This is only 1, 2 sig figs. So remember, this zero shows exactness. These zeros, these zeros, these zeros are placeholders. So the same idea, 3 different answers here. They're all different numbers of sig figs. Take a look. This is only 1, 2 sig figs. These are placeholders. This is showing that those are not just placeholders. There's a decimal there to show exact. So 1, 2, 3, 4, 5. That's a trick we sometimes use. That little decimal there with nothing after it says these are not just placeholders. They're exact now. And then 1, 2, 3, 4, 5, 6. These are not just placeholders. There's a decimal and a zero after to show that it's all exact. So zeros are the thing you have to think about a little bit more because they can be sometimes kind of weird. And then we got this one. What did you say for this answer? 1, 2, 3, 4, 5, 6. They're all significant. They all give the more specific part of your answer. Excuse me. So these are all sig figs. How'd you do on this? Look back at if you got any wrong, see if you need to review any rules, or see if you need to jot down a question and ask me during office hours or in next class. Take a look at this. How'd you do? All right, take another break. So whether you need to actually physically go take a break or just take a break right now to think about those notes, look back at your notes, see if they make sense, and write a level 2 question. What you could do is you could pick any made up number and say how many sig figs are there. Make sure there's some zeros in there because that makes it a little bit trickier. Or you could pick 2 numbers and you could say, compare them. What do they have in common for sig figs? What's different about them? Any other type of explanation, explain the sig fig rules, that kind of stuff. Take a break. If you need other guides for Costa question sentence starters, remember there's that guide on Schoology. All right, welcome back. So now let's combine those 2 things we just did, math problems and also these ideas of sig figs. So when we do a math problem, how do we know how many sig figs there are? Well, it's that thing they say about a chain. What's that saying about chains again? You can only be as strong as your weakest link. So write this down. An answer in a calculation can only be as exact in terms of sig figs as the least number of sig figs in the equation. So if you have a whole bunch of measurements that you're using to do a math problem, you have to look at those measurements and count the sig figs. Your final answer has to be rounded off or chopped off at the smallest number of sig figs in the equation. That's the idea. Pause the video if you need more time to write down this phrase, but otherwise let's practice it. So here we go. When we're multiplying and dividing, here's what we do. Count the total number of sig figs for each value in the calculation. So if we add these 2 numbers, this has 1, 2, 3, 4 sig figs. This one has 1, 2, 3. Okay, so 4 sig figs, 3 sig figs. Then you do the math like normal. When you get the answer on your calculator, your answer can only have as many sig figs as the least number of sig figs. So when you do the math answer and you get this, 86.332, so nothing changes about how you do the math, you get a math answer. But now we have to think about the science answer because we have to earn the numbers we write down. This has 1, 2, 3, 4, 5 sig figs suddenly, but we can't have more sig figs in our answer than the least number of sig figs in our calculation. So I can keep 1, 2, 3 sig figs. I look at this number for rounding, which it does not. So these numbers just fall away. They were pretend made up numbers for math. 86.3 is the science answer. So remember, we're doing science math, not just random math. Random math says, sure, this can be the answer because that shows the math function. But science says your final answer can't suddenly be more specific because remember, every number is earned. So these numbers, these 3 and these 2, never existed in science. The science answer is 86.3. We rounded it off, chop it off to give the science answer. Why? Remember, the smallest number of sig figs in the equation was 3. That's why it chopped off at 1, 2, 3 sig figs. So it's still the same math equivalent, right? 86.332, same math as 86.3. But the difference is you need to figure out what part of this math answer is true in science. That's the new thing you're kind of thinking about. All right, let's try a couple more examples of this. Let's do these math problems in steps. If you take 4.14 times 1.9, all right, so maybe you're trying to figure out the area of a little cage or something. 4.14 times 1.9, your calculator says this is the answer. But wait a second, this has 1, 2, 3, 4 sig figs suddenly, but this number was not very specific. This number was even less specific than that. So your answer can only have 1, 2 sig figs because your smallest number of sig figs in the calculation was 2. So then you go back to the calculator and you say, I can keep 1, 2 sig figs. I look at this number for rounding. It's higher than 5, so it does. So it rounds this to 7.9. And then we always got to make sure we don't have any naked numbers. Make sure you have labels. So 7.9 is the science answer that matches the numbers we used in the calculation. Your final answer can't have more sig figs than your least number of sig figs in your problem. Try this one. 81300 divided by 380. Okay, so do the math like normal. Your calculator gives you an answer. Whoa, oh my gosh, that's a crazy number of sig figs. Where did all those numbers come from? Well, remember, the calculator just does math, and that's fine. We as scientists have to change the math answer to give the science answer. This only has 1, 2 sig figs because this is a placeholder. This has 1, 2, 3. These are placeholders. So your final answer can only have 2 sig figs. So I can keep 1, 2. I look at this number for rounding, which it doesn't, but then it turns into a placeholder because we can't keep an answer of 21 because this answer was 213 point blah, 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 blah in math. So then a placeholder goes in place of the 3 to say that the final answer is 210. So it's still 200 something, and in fact, it's 201 something, and then the 0 says it's 210. 210. 2 sig figs with a placeholder to say it's 210 because this was 213. So we had to round it because this final answer on the calculator was way too specific. Our measurements can only have 2 sig figs. So the science answer is using sig fig rules. The math, you just do that on your calculator like you normally would. All right, now let's try a couple more. How about this one? So we have 0.00510 divided by 10. All right, once again, calculator does the math like normal. Awesome, great, nothing to change. But then this measurement only had 1 sig fig. So we have to round this off to just 1 sig fig. These are all placeholders. We get them for free. So our final answer will be 0.00005. That number chops off. We can't be more specific than this least specific measurement. This is only 1 sig fig, so our final answer can only have 1 sig fig. We chop off that 1 because it never existed in science. So these were placeholders. We get them for free. 0.00005 is the 1 sig fig that we get. How about this one? Do the math quick. Math calculator says, yep, 148500. Great. But look, this only has 1, 2 sig figs. This is a placeholder. This measurement was specific, 1, 2, 3, 4, but the rule says you can't be more specific than your least number of sig figs. So we can only keep 2. So I can keep 1, 2 sig figs. I look at this number for rounding, which it does. So I can keep 1, 5. Well, wait, but our answer is not 15 because this answer was in the thousands. So I keep the 1 and the 5, and all of these turn into 0 placeholders. So 150,000, because you have to have a similar math answer. So sometimes we put in placeholder zeros to give us the same kind of math answer. So 148,500 rounded up to 150,000 with only 2 sig figs. Okay? Go back and rewind the video if you need to kind of look at these examples again, see if they're making sense, write them down if it would be helpful. Otherwise, it's okay if you were just listening. And now it's time to take another break. But this is your third break, which means we're pretty much done with our notes. So a level 3, maybe you need to kind of help like defend or predict. When would using these sig fig rules be useful? When might I care about this as a scientist? Or generalize the steps of sig figs or the rules of sig figs. So summaries, those kinds of things. All right. Okay. Now I want you to, we're done with our notes, but I want you to open up the intro practice assignment. So from Schoology into Notability. So pause the video and then go get that document ready. Are you ready? Okay, so what you're going to do on this practice assignment, the first page is, we're going to answer this question. So do this with me on this assignment. So again, go back. If you didn't actually open this assignment, DA intro, go back and do it because we're going to fill in some things together on that first couple pages. So the process for DA, also thinking about sig figs. So let's say we wanted to answer this question. How many miles is a 5K race? Well, first we have to know where I'm starting. So you have to know that 5K is really 5 km for kilometers. So fill that in. So once again, if you didn't actually open this is not notes. I'm starting the assignment with you. So open from Schoology into Notability, the assignment called DA Intro, and we're going to write down some things together. So the first thing you do is you ask yourself, where am I starting? Look at the problem. It gives you 5K. That means 5 kilometers. Then what am I trying to get to? It says, how many miles? So the units I'm trying to get to are miles. One more time. You are actually writing this in on the DA intro assignment. These are not notes that you're writing down. We're writing down on the actual assignment. So from Schoology, open and put into Notability the DA intro assignment. So I'm starting with 5K to answer this question. How many miles is a 5K race? I'm trying to get to miles. Third question, what conversions do I need? Do I have a conversion between kilometers and miles? Yes, I do. I know that 1.61 kilometers equals 1 mile. There's my conversion to get from 5 kilometers to miles and answer this question. That is the conversion. There's a lot more conversions on the bottom of the next page in this assignment. So there's a lot of conversions you don't have to have memorized. They're on the assignment. So look up your conversions so you have them between whatever questions it's asking for. All right, let's keep going. So number 4 says, set up the units so they cancel until you get the units that you want. So you write down 5 kilometers. That's the first thing you write down. Write this down with me. Then I need to set up conversions so that kilometers will cancel. Well, remember that dividing rule. If you have the same thing on the top and the bottom, that considers canceling. So I'm going to put the 1.61 km part of my conversion on the bottom and 1 mile on top. So kilometers will cancel. I'm left with miles. That is the units that I want for this problem. So now I do my math like normal. So I do on my calculator, solve, label in sig figs, 5 times 1, numbers on the top multiply, divided by 1.61. Numbers on the top multiply, numbers on the bottom divide. 5 times 1 divided by 1.61. This is what the calculator says the answer is. Oh, but we got to do that new sig fig idea. This measurement was not very specific. 5, that's one measurement. This has 1, 2, 3, but I can only keep this least number of sig figs. So I can only keep 1. One number, 3, that is my estimated science answer. If I wanted to be more specific, then maybe I would have measured 5.0. That would have been 2 sig figs, 3.1. Sometimes that's usually what you see, 3.1, because they're saying that this first measurement of 5 is exact. But using our sig fig rules, we can't be more specific in our answer than our least specific number. So 3 miles would be your sig fig science answer. Okay, let's do one more together. So the next part of this DA intro assignment has different puzzles. There's blanks and the answer is given, and then I give you different conversions. So it's not the same as this, but it's that idea where like I tell you different pieces of the puzzle, you put them in the right spot to equal the answer that was given. Remember the 4 steps. Think about, where am I starting? That goes in your first blank. Where am I going? That goes in your last blank. What conversions do I need? Those go in the middle blanks so that you cancel out the units that you started with and you get to the unit that you're trying to find. Your final answer you solve, multiply on the top, divide on the bottom, so you get the right label, and then you have to think about sig figs. After we do the first page, and we've done a couple examples together, the third page has 5 examples for you to try to do on your own, doing the same setup as the ones from the first 2 pages. Let's do one more together. Practice problem number 1. So this is on your, again, this fills in right on your intro assignment, DA intro. Let's do number 1 together. How many centimeters are in 18.5 feet? Well, right away, there's my given. The given always goes in the first blank. So write this down. I know this is in blue, but go ahead and write this down with me. Here are some things that I know. 1 inch equals 2.54 centimeters. Okay, great. 12 inches equals 1 foot. That's like an exact definition. This, somebody had to measure, so this counts for sig figs, but all these other numbers are just kind of definitions. They're exact sig figs. I'm trying to figure out how many centimeters this is. 18.5 feet was measured. That goes first. How many centimeters? So I know that my last thing, my last blank that won't cancel is centimeters, but I do have to cancel feet. Well, look at the pieces I gave you. 1 inch equals 2.54 centimeters and 12 inches equals 1 foot. Oh, hey, foot is the same as feet. So if I put feet on the bottom, it will cancel. But you can only put stuff on top that is equal. So you can only put stuff on the top and the bottom that are equal to each other. That's why I didn't put anything underneath 18.5 feet, my given, because there's nothing equal to it. This is the number I'm trying to change and the unit I'm trying to change. So look, feet and feet are both on the top and the bottom, which means they cancel. So when we say your words have to cancel, it means you have them in the opposite spot. So if I'm trying to cancel feet and feet is on the top, feet has to be on the bottom in the next step in my conversion. Well, now I'm at inches, but the problem wasn't asking for inches, it was asking for centimeters. So the next part of my puzzle is, how do I cancel inches? Inches on the top now, so I need it on the bottom in the next step, in the next conversion. Well, look, I have this conversion. 1 inch equals 2.54 centimeters. So inches is on the top. So to get it to cancel, I need to put it on the bottom here. But I can only put stuff on the top and bottom in the same conversion if they're equal to each other. So 2.54 centimeters can go on the top. Inches on the top in this step, inches on the bottom in the next step means it cancels. And I'm left with centimeters, which is what the problem is asking for. So you're ready for your calculator. Multiply all the numbers on the top. Divide any numbers on the bottom. So really you would type this into your calculator, 18.5 times 12 times 2.54 divided by 1 and divided by 1. Now you can skip the ones if you want to, but some people like to type them in just so that you've got the whole thing. This is what the calculator says. Wait, but this is what I said the answer was. Don't forget about sig figs. So I have 1, 2, 3 sig figs here. This we said was just a definition. There's no error or specificness in this. It's just a kind of exact. And this has 1, 2, 3 sig figs. So I can keep 1, 2, 3 sig figs from my calculator. I look at the next number for rounding, which it does. That's why the final answer is 564. So the number rounds, these numbers chop off because you can't be more specific. This has 1, 2, 3, 4, 5 sig figs. That's not allowed. We can only have 3 sig figs. So it rounds to 564. Good job. No, actually, awesome job. Whew, that was a lot to think about, but you've got a couple example problems done on this intro assignment already. Now you're just going to keep working through those examples. So that's the end of day 1. Go back to your notes if you need to and finish any Costa questions. Go back to your notes and do your summary. Kind of think about, what did you learn today? And then keep working on that DA intro practice that we just started. Remember, I have office hours if you have any questions. And then another quick backwards reminder, that types of reactions lab report from earlier this week, remember that's due on Friday. So if you're watching this video on the day it was assigned, the types of reactions lab report is due on Friday. If you were watching this video at any other time, don't worry about it. Just make sure today's information makes sense. And then I will see you at our next Zoom, but remember, you can always use office hours if you have questions. Thanks for a good day. Haha, like DA, day. Bye.